you think about number 6. So first thing I want to mention is, do you guys see that b to the -2 is on the top and b to the -2 is on the bottom? Okay, what do we normally do with negative exponents? Flip them, right? Okay, and if I flip this, it's going to come down here and become positive, b to the +2. And if I flip this, it's going to come up here and be b to the +2. And then what am I going to do with those? Cancel them out. So what I'm saying is you can cancel them out right there. Just because they're negatives doesn't mean that they can't be canceled. It's still a giant 1 because it's still the same thing on the top and bottom. Okay, what else can be canceled in this problem?
Okay.
No. The 3's. Okay, hold on to the thought with the a's. So a to the -1 over a. So this is what's left after my canceling. This one needs a reciprocal, so it's going to go down to the bottom. Yeah, so I have a, the original a, times a to the +1 now. Nothing left on top. And so this is 1 over a squared. Okay, so the math moral of the story here is you can cancel them when they're exactly the same exponent, but you can't cancel them if they're opposite number exponents. You have to move it. So remember, canceling only when they're exactly the same. Okay, next one, scientific notation, your favorite. This one's a multiplication one. So we're going to do 4 times 4.86 times 10 to the, so we multiply the numbers and we add the exponents. Multiply the numbers, add the exponents. And now I need to show you my birthday present from Mr. Talbot, one of them. Behold its beauty and glory. It's my favorite color. I like, I'm super excited to come to work so I could use my new calculator. Anyway, 4 times 4.86 is 19.44 times 10 to the 5. Okay. So this is where it gets to be more challenging. Where does the decimal need to go? One place, that's technically down, but one place to the left, because you want it to be 1.944. Okay, and if I make this 19.44 to 1.944, I add 1, yeah. Okay, that's it for warm-ups. Don't put your packets away. We're going to use a resource page in the classwork today that is this one with all the number 36s on it. So find this resource page in your packet and then just set your packet aside for a second. And then go ahead and start working on your notebook. I'm gonna bring you guys color pencils. If you could please, at the end of the period, put them back into the box and not just be lazy and throw them into the basket. That would be amazing. Also, if you're someone who cares about that sort of thing, like I am, there's a colored pencil sharpener right here. So just grab that. Okay, so for number 35, we are going to just write a little summary of what we've been doing in class with slope. And this will help us remind ourselves what this is for the quiz. So you guys, if you forgot, you have a quiz today. One of the questions is to find the slope on a table and graph. So we're going to talk about that right now. Okay, first we're going to talk about the situation if you have a tile pattern, which is the very first resource page we did, which was this one, if you guys remember. And when we had a tile pattern, do you guys remember how we found the equation? Y equals, what was the equation? What? Yes, but what was M and what was B for a tile pattern? Yes, Mackenzie. Perfect. Y equals growth times X plus figure 0. And one of the things I wanted you to know about tile patterns is if you graph the dots from the table, don't connect them for a tile pattern. Don't connect the dots. Okay. So looking back here, this was number 11 from Tuesday. How did we get the 5? That's the growth each time. How did we get figure 0? We looked at the table and how many tiles were in figure 0. Okay. So that's where we started this chapter, was with tile patterns. Then we moved on to functions. And we change up the vocab a little bit, but it's the same thing. So it's y equals slope times x plus y-intercept. This is exactly the same thing. It's just written in terms of a function instead of a tile pattern. And then as Mackenzie said very brilliantly, because we're lazy humans, we make letters for those things and we say y equals mx plus b. M is the slope and b is the y-intercept. A lot of people say slope and start instead of slope and y-intercept, but same deal. Okay, now from a graph, we use the letter M for slope. And there's a couple of different ways to represent it. Change in y over change in x. Or rise over run. You guys remember when we made the slope triangles and we counted the boxes? That's what I'm referring to here. This type of line has a positive slope. There's actually 4 different types of slopes. This one has a positive slope. This type of line has a negative slope because it's going downhill. This type of line has a 0 slope. We talked about that on Tuesday. Was it Tuesday? It was Tuesday. Okay, and then there's another one, which is vertical. And a vertical slope is called undefined. Undefined slope is because it's a situation where you're trying to divide by zero. And you guys know about dividing by zero error, right? So that's what happens there. I quoted you there. Okay, last thing for number 35. B is the y-intercept. I want you guys to draw a little visual picture because some people, they get confused about y-intercept versus x-intercept. So I always want you to picture that as you start as figure 0 on the y. And then always has the point 0b. This is a basic summary of everything you've done in this chapter so far. The only thing we didn't do was draw the triangles underneath in color and then count the boxes, but we talked about how to do it. So this is like your little summary page. On your quiz today, you're going to be asked to find the slope from a table and the slope from a graph. So really quick, before we move on to, we're going to actually do that in number 36, luckily, but I want to look back at this problem. You don't have to flip your notebook, just look up here. Just pretend that you have this table. How do I find the slope from this table? The answer is already there. Yes. Yes. So the slope from the table is how many tiles it's going up each time? So 12. So when I ask you on the quiz to find the slope from a table, you're going to look and see how much it's going up each time, and the slope will be 12. You don't have to find the whole equation on the quiz. You just have to find the slope. Okay, now how do I find the slope from a graph? I make a triangle, count the boxes of the height, count the boxes over the base. 12 over 1 is 12. You should be able to do it from this or from this. Okay, just checking because I care about you and your quiz. All right, now if you guys could find that resource page we were talking about, number 36. And you'll probably want a straight edge and a colored pencil. I'm just going to do the agenda while I have the screen up here. So we're doing 35 through 38. We already did 35. That was our little review problem. 36 is on the resource page. 37 is actually going to be notes on how to find the slope without graphing. That's for us, those of us that are lazy and don't like to graph. Yeah, and that you're going to like that problem. And then 38 is very quick. Then we're going to have our quiz. The homework tonight is a worksheet in the packet. Can you guys all lift up the page that you're on for 36 and just look at the next 2 pages? That's the homework. You see it? So the first page has 8 slopes. If it takes you more than 5 minutes to do that entire page, you're doing something wrong. You literally draw the triangles, count the boxes, rise over row. There's That should really take like 4 minutes. And I'm gonna give you time in class. Okay, does everybody understand what the homework is? Also, you can tell Willy Wonka how you feel about the 2 pages. I love these Willy Wonka memes, they're great. Okay, anyway, all right, now let's go to number 36, which is in the book. Which requires a lot of clicking. Chapter 2, 214. Full screen. Okay. All right, so this is what we're going to do on the resource page. Line A goes through point 25. Okay, everybody graph the point 25 on your first one here. So 25. I feel as though I should probably work an erasable pen. 1, 2, 1, 2, 3, 2, 5. Okay, everybody got the point 25 graph. Okay, you guys, I'm gonna come around and close your Chromebooks in very mean fashion in 3, 2, 1. This is completely inappropriate, and you can get this back later. I'm not, it's not my concern. You guys have to have respect for experts. The expert is speaking. That's me. And you're not disrespectful to that person. Okay, here's my question. Can you guys tell me where the line is? Where is the line going to be with that 1.25? It's a trick question. There's actually no way to tell where the line's going to be because you only have 1 point. There's actually an infinite number of lines that go through that point. We're not going to draw them all because we're too lazy, but this is not possible. Not possible to find the equation from just 1 point. Okay, do you guys know what we need to find an equation? 2 points. That will give you enough information to make the triangle and figure out where the start is. Or you could just have the growth and the start. There's a lot of different things, but 1 point's not going to do it for you. Okay. Now, line B has a slope of -3 and goes through the origin. Okay, what point is the origin? 0, 0, right. Okay, so for B, graph a point at the origin. And then a slope of -3. What does that mean for us? What do we do with a slope of -3? How do I graph that? Yes, dear. Perfect. Okay, so this is kind of hard because these little tick marks are tiny, but every time you go up by 1, it goes down by 3. Up by 1, down by 3. Up by 1, down by 3. And then you get a couple of points in there and you can make the rest of your line with a straight edge. Okay. y equals, slope was -3. And what's the start in this one? 0. Okay, now you can leave this as your final answer. This is always a perfect final answer, 100% full credit, never a problem. But if you're a person who likes to tidy things up, you can leave it like that. Nope. It's just your preference. Okay, C. Line C goes through the points -3, -2, and 3, 10. Can you guys graph me the 2 points, -3, -2? Kind of hard. And 3, 10. I think I did 2. No, I did it right. Okay, take your straight edge. Okay, do you guys all think that the y-intercept is 4? Did you guys get 4? Did anyone else get 4? It's kind of hard to draw it. You got 4. Okay, just try to like put in that dot at 4. I think it's supposed to be 4, but this graph paper is not great. Okay, what I want to do next is I want to make my slope triangle. Okay, what is the height of my slope triangle if this is 4? 6. And what is the base? 3. Okay, so the slope is rise over run. 6 divided by 3 is 2. Is it a positive slope or negative slope? Positive. Okay, I just want to put that in your mind so you don't forget that that's a thing. Okay, so what is B in this problem? 4. B is the y-intercept dot. How did I get what? Oh, this was 10 and this was 4, so I just did 10 minus 4 in my head. It's this graph paper. It's just not great. Y equals 2x plus 4. Don't worry, when we get done with number 36, I'm going to teach you the way to do this without having to make graph and make a triangle every time. So it's going to be good. Okay, line D has the following table. Can you guys graph these 4 coordinates, please, on the D one? Oh, there's halves. That's not going to be good. Okay. 2, 1, 3, 3.5. Sure, sure. 4, 6, 5, 8.5. Yikes. Next question. Did anybody backtrack it down to -4? Okay, just checking my answer. So what I did was I graphed the 4 points it gave me. Then I backtracked it. I went down 2.5, back 1, down 2.5, back 1. Okay, now I'm going to draw my slope triangle in, and I'm just going to use nice coordinates. I'm going to use the lattice point ones, not the ones that are halves. Okay, what's the height of this triangle here? 5, and the base is 2. I think it's 2. Yes, dear. I know, it's okay. I picked the whole number ones because I was too lazy to do the ones that were 0.5. So I did the point. Okay, hold on. What point is this one? That's 2, 1, correct? Okay, and what point is that one? 4, 6, 4, 6. I did those two because they have whole numbers on purpose. I didn't want to do the ones that have some 5s and 1s for the back. So this is actually a really great thing that you guys pointed out. You can pick any 2 points you want. It doesn't have to be the 2 that are right next to each other. Pick 2 that are easy. You'll get the same answer in the end. Okay, is it positive or negative slope on this one? Perfect. Y equals 5 over 2x. Whoa. -4. Okay. Line E has a slope of 4. Everybody draw a slope of 4 on number 36E. Draw me a slope of 4. Yes, sir. Not while I'm teaching. Just give me a few minutes. Slope of 4. You're supposed to be confused. I didn't tell you where to start for your slope of 4. This one is also impossible to find the equation. everyone would have a different one, but let's talk about how to graph the slope of 4. What I like to do is I like to put the 4/1 and I'll say, like what Landon said was perfect. Every time I go up 1 or over 1, I'm going to go up 4. So let's just start at a random spot. Let's start here. Every time that I go over 1, I'm going to go up 4. It's kind of pretty steep, right? Hard to draw on this graph paper that CPM has supplied for us. Because of the way this is scaled, see how this is 5? But each little baby tick mark is actually 4. That's why I don't like this graph paper very much. Because every box is 2. But I see why they did it. They wanted to fit it all on there. Okay, are we almost done? Line F goes through point 8, -1, and has a slope of -3/4. Okay, so everybody start with graphing me the point 8, -1. All right, there it is, the point 8, -1. Okay, how am I going to graph a slope of -3/4? This is what I like to do. I like to go down 3 boxes for every 4 I go over. So I go down 3 boxes for every 4 I go over. Now what do we need to do to get the y-intercept? We can make a line, but I bet it's not going to be great. What I suggest we do is backtrack our points up closer to the y-axis so we can see it better, especially with this graph paper. Okay, so I'm going to backtrack up, which means I'm going to go up 3, back 4, up 3, back 4. I didn't go 4, huh? Yeah, I did. No, I didn't. These 2 boys right here are talking and they're triggering my adult ADHD. 1, 2, 3. No, I did 2. That gives me a much clearer picture of the fact that it's at 5. I probably could have done it with the line. Almost there. Yes, sir. What are you talking about? Can you look at the screen to see the problems when I put them up? You can always grab a book. Okay, last one. Customer G sent the following table. Okay, can you guys graph these points, please, on number G? Number G, I just said number G. 0, 1, 1, 2, 2, 4, 3, 8. 16's off the graph. Just try to wing it where it would be. Kind of. Yep. You should notice something wacky while you're graphing it, though. Yes. I just said that. You're just going to have to estimate. I just threw the point, up in the white space up there above the graph. Like that. I just gave it a good go of where I thought 16 might be. It goes to 12, so you could sort of estimate. But there's a wacky problem here. Anybody see the problem, the issue? It's curving. Yeah, it's not a line. Can't find an equation of a line if it's not a line. This is a curve. And this is just a little indication of what's to come in your math career. Not always going to be a line. This is called a exponential. Not a problem. It's an exponential function. We're going to do this in chapter 8 in this class. And you can tell because it's doubling. Okay. You guys are done with the packet for the moment, but you might want to flip to the homework. Just have that page open. Okay, so now's the moment. I'm going to teach you how to find the slope with no triangle. Whew. Don't have to graph the points at all. It's going to be great. Does anybody know how to do this already? I'm not surprised. Okay. This is -11, -19, and 7, -16 there. Okay, so first thing you need to note is there is a slope formula. And it goes like this: y2 minus y1 over x2 minus x1. Okay, why are the y's on top? Exactly, because it's rise over run, or change in y over change in x, or height over base. So that's the biggest mistake people make is they put the x's on top, but they know rise over run. So you have to remember rise over run. Well, if you're going to use the formula, y's have to be on top. Okay, next thing you do is you label your coordinates. Your first coordinate is going to be x1, y1, because it's an X, Y coordinate. And your second coordinate is going to be X2, Y2. Natalia kind of set me up for this earlier because she said, how did you get the 6? And I said, I subtracted 10 from 4. All I was doing was subtracting the 10 minus 4 there. So I sort of did it earlier. But anyway, okay. So slope equals. Okay, so I'm going to follow the formula. Which number is Y2? 7. And which number is Y1? 5. And X2 is also 5. And X1 is 6. Okay, 7 minus 5 is 2. 5 minus 6 is -1. And so that is a slope of -2. Okay, how would we graph that? We'd have some point, and then you would go down 2 for every one that you went over. So this is a slope of -2. Okay, now I made up number B. B is not the same one as the one in the book because you guys are really struggling with the subtraction of negatives and things. So I made this one up in my head because it was just full of negatives through, like, almost everything has a negative in it. Thanks, Mrs. Talbot. You're welcome. X1, Y1, X2, Y2. M equals. Okay, you're going to be very careful. What is Y2? Beautiful. Okay, minus. What is Y1? Don't just put minus 19. It has to be minus -19. X2 is 7 minus -11. Okay. Since the first week of school, we've been working on minus and negative makes it plus. Yes. So -16 plus 19, 3 over 18. And 3 divided by 18 can be reduced. I'm going to divide both by 3, 1/6. Okay, how would a slope of 1/6 look? You'd have some dot, and you're going to go up 1 for every 6 you go over. So up 1 for every 6 you go over. I'm going to do this one Jupiter style and put it on top. Okay. Last question, number 38. It's a very quick question. Show me with your arm the steepest possible slope. This. Okay, what kind of a line is that? What is it called? Vertical. Okay, vertical lines have the steepest slope. Vertical lines look like this. That's as steep as you can possibly go. The line is so steep that it can't be divided. Yeah, it can't be divided by 0. Yeah. So we call it undefined. Undefined slope. I like to think of it as a cliff. Falling off a cliff might give you an undefined situation. I don't think that senior citizens are going to the mall to walk on an undefined slope. Imagine the poor senior citizens trying to walk on the undefined slope. So, yeah. Kunor, honey. Okay, all of you guys, we need to wait till I'm done teaching. Please don't ask me to go to the bathroom in the middle of teaching. This is what we need to talk about, respect for experts. It's not an appropriate question in the middle of class. After I'm done with class and I stop the video recording, then you can definitely ask. Now we have a line, I believe it starts with Hadley.